Welcome to Brain Vision.
We start with this integral and we'll get the normalization this way. So proceeding, we see that if we multiply the wave function by itself, we're going to have three terms that result, including a cross term. And this means then that we have three integrals that we'll need to evaluate. So we'll go ahead and evaluate those three integrals and then we'll put them together. So the first integral is sine squared pi x over L. This integral is given here. So the signs will actually vanish since we have sine 2 pi and sine 0, and those are 0. And this integral of sine squared pi x over L is just L over 2. Next, we have the integral for the cross term, that is 8 times sine of pi x over L times sine of 2 pi x over L. And carrying out that integral from 0 to L, we have two terms here that result. Now, whether we evaluate them at either endpoint, it'll turn out that we get sine of pi or sine of 3 pi, but those are both 0. So this integral is actually 0, as it should be, because we have a sine of pi x and a sine of 2 pi x, and these are known as orthogonal functions. So if we take the integral of their product, we should get 0 over this finite interval. Next, we have the integral of sine squared of 2 pi x over L. So next we'll get its integral. And here we have just a sine of 4 pi that would result, but it is also 0, and we're left with 8L for this integral. So when we take these integrals and we substitute them back into the overall integral, we have a squared times the total integral, and this overall quantity, this total integral times a squared, needs to equal 1, because after all, we are normalizing. And we substitute in what we obtain, namely L over 2 plus 8L times a squared equaling 1, and we can get a value for a. So in doing that, we get a common denominator for L over 2 and 8L, and we have a squared times 17 over 2 times L equaling 1. And then it's fairly simple to get a. So a ends up equaling the square root of 2 divided by 17L. So now we have another wave function that we'll look at real quick, and that is cosine, or rather a times cosine of pi x over 2a plus b times sine of pi x over a on the interval from minus a to a. And we'll go ahead and we'll take the integral of its square over this interval. And again, we're going to end up with a cross term. And this square needs to equal 1. So we have that. And as we go forward, we'll go ahead and we'll evaluate each of the three integrals that we have one by one, like we did earlier for the other wave function. So for the first integral, we have cosine squared of pi x over 2a. This gives us, in evaluating at minus a and a, we evaluate the signs, those go away, and we simply get a for this first integral. Next, we look at the integral for the cross term, which is 2ab times cosine pi x over 2a times sine of pi x over a. That's a cross term that's similar to the cross term we had before. And again, it will be 0, but I'll go ahead and just write out what it evaluates to in the middle so you have it, and you can always just look at it and see why it becomes 0. And basically, it becomes 0 because when you substitute a inside of the first cosine, you end up with pi over 2. So cosine pi over 2 is 0. You also will substitute minus a into that first cosine, and you get cosine of minus pi over 2, which is also 0. Then for the second cosine, you get either cosine 3 pi over 2 for a, and then for minus a, you get cosine negative 3 pi over 2, and those are both 0. So therefore, you get 0 for the second integral. Now we come to the third integral, and that is the integral of sine squared pi x over a. So we take this integral, and we go forward, and we get, let me scroll down a bit here. All of these integrals can be obtained through integration by parts or an integral table, either way, but I just simply give them. And we get this. Here we have sine 2 pi and sine minus 2 pi. Those go away, and we're simply left with 2a over 2, and of course that's just going to be a. So when we put these integrals into our overall integral, we have a squared cosine square of the, well, let me rephrase that. We have a squared times the cosine squared integral. Our cross term integral goes away, so we don't care about that one. And we have b squared times our sine squared integral. And this all has to equal 1. But remember, the cosine squared and the sine squared integrals were both equal to a. So we have a squared a plus b squared a equaling 1. And now we have our relationship that we want. So a squared plus b squared equals 1 over a, and that's our final result.